Hello students, I hope all you like the first session which we have discussed about the matrices. Now today in the next lecture we will discuss about the algebra of matrices. Algebra, it means addition, subtraction, multiplication. So first of all, the addition of matrices. So how it is possible? Let us suppose we have two matrices. Let us suppose A is a matrix Aij of order m cross n, and B is another matrix. This is Bij of the same order n cross n. So you have to check here the order of both matrices will be same. Then the two matrices can be add or subtract each other. So we have seen this is the first matrix A, this is the second matrix B having the same order, then we can add them. And how we can add? The A plus B can be explained. A plus B, it will form a new matrix, and this new matrix of same order, this is m cross n on. Order will remain the same. And here we will adding only the corresponding elements, of the given matrices. Let us suppose, for example, let us suppose A is any matrix and this is 2, 3, 4, 5. Order is 2 cross 2. And the second B, this matrix is 1, 0, 3, 4. This is the second matrix of the same order 2 cross 2. Now we have to find the value of A plus B. First of all, we will check the order. Here we have seen the order of both the matrices are same. This is 2 cross 2 and this is also 2 cross 2. So we can add these matrices. How we can add the matrices? The corresponding elements will get added. That is 2 and 1. 2 plus 1. This is 3 and 0. 3 plus 0. 4 and 3. 4 plus 3. 5 and 4. 5 plus 4. The order remains the same. This is 2 cross 2. And finally we will get the matrix. This is 3, 3, 7, 9. This is our result. What happened? If we have, let us suppose the matrix C, and the order of this matrix, we will suppose this is 2 cross 3. Let us suppose 1, 0, 1, 2, 3, 5. Can we add A and C? No, this is not possible. Why? Because we have seen the order of the matrix A is 2 cross 2 and the order of matrix is 2 cross 3. The order is not same. Order is not same. That's why we cannot add A and C. I hope you understood. Only the same order matrices can be added as well as subtracted from each other. Now, what are the properties of the addition? We will talk about the properties. So addition, properties of addition. The first of all, let us suppose again we have two matrices of the same order. Then A plus B and B plus A will remain the same. That is, they follow the commutative property. It means the addition of two matrices are commutative. I hope you understood. This is A plus B and B plus A remains the same if the order of both the matrices will be m cross n. This is the order of both the matrices A as well as B. The second property, if we have three matrices of same order, then A plus B plus C, this is equals to A plus B plus C. As we have already seen that the order will be same, then the addition will be done. So here the order of all the matrices are same, and if we will add A and B, then we will add C, or we will add B and C, then we will add A, then it remains the same. That is, it follows the associative property. The first one is, it means the addition of two or more matrices follow the commutative rule and the associative rule. Now, the next property, that is existence of Existence of identity. Existence of identity means what? Let us suppose we have a matrix A. We have a matrix A. Let us suppose A is a matrix and order of this matrix is given m cross n. If we will add null matrix to this, null matrix, what is null? Null, it means this is 0, 0. 0 is the null matrix. Yesterday we have discussed about the null matrix whose all elements are 0 and this matrix is called the null matrix. And A plus 0 is equals to 0 plus A. What is 0? This is a 0 null matrix. This denotes the, and this will be equals to A. Hence, what is 0? What is 0? 0 यहाँ पे क्या है? 0 identity है. This is the identity matrix for A. Because you can see 0 plus A or A plus 0 remains the same. This is equals to A. And the next property, that is existence of inverse. Again, we will assume that is A is a matrix Aij of the order m cross n. Existence of inverse. It means we are talking about the additive inverse of A. If A is a matrix, what will be its additive inverse? Additive inverse, it means what? If we will add some matrix into this and the remaining answer will become null matrix. It means if we will add A to the matrix minus A, then what happens? We will get a null matrix. This minus A is called the additive inverse of the matrix A. I hope you understood. This is A plus minus A equals to 0, or either you can write minus A plus A equals to 0. So minus A is what? This is the additive inverse of the matrix A. I hope you understood all the terms which we have discussed about the addition of matrices and the property of addition. So first of all, you can see it follows the commutative property. It follows the associative property. Here the identity element for the matrix A, addition, for addition the identity element is null matrix, and for inverse, additive inverse of this matrix is minus A. Hope you understood all the terms. Now we will discuss some examples regarding this, as we have discussed that how we can add or subtract two or more matrices. Now we will start with the next topic, that is multiplication of matrix by a scalar. Multiplication of matrix. Scalar. What is scalar? Scalar, it means that is 2, 3, 4, 5, whatever. So you can see here how we can do this multiplication of a matrix by a scalar. So let us suppose we have again a matrix A, Aij. We know the symbolic representation of A. This is Aij, where Aij is an element. This is order of this matrix is m cross n, and let K be any scalar. K be any scalar, it means it will be 2, 3, 4, 5. Then what? Then the matrix obtained by multiplication, every element of A by K, is called the scalar multiplication of A by K, and it is denoted by K into A. This is, if we multiply K with A, then what happens? All the elements of the matrix A are multiplied this scalar A. We can also represent this like K into I. So it will be clear with the example. Let us suppose we have a matrix A, 1, 2, 3, 4, and the scalar K is given. Let us suppose 3. Anyway, 3 we have taken, K as a 3. Then what is 3? This is what is K into A. K into it means 3 into A. What will be 3 into A? So here 3 is a scalar, and this scalar will be multiplied by all the terms, that is 3 1s are 3 and 3 2s are 3 3s are, and 3 4s are. All the elements get multiplied by this 3. So this will become 3, 6, 9, 12. I hope you understood how we will do the scalar multiplication with a given matrix. Now, the sum properties of the scalar multiplication. Some properties of scalar multiplication. See this. Let us suppose again we have a matrix A and B. A equals to Aij. The order is m cross n. Whatever the order you can take, that is B, Bij, and the order is again m cross n. We have suppose two matrices are there, and let us suppose K and L are two scalars. These are the two scalars, K and L are the two scalars. And the first property, if we multiply K by the addition of two matrices, then what happens? This scalar K will be multiplied by A and multiplied by B. This is the first property. The second one, if K and L are the scalars and the addition of these scalars are multiplied by A, then this can also be written as K into A plus L into A. The third, next property, this is K into L. The product of the two scalars multiplied by A, then it can be written as, this is K into LA. This can be written as, or this also can be written as L into K into A. The next one property, if minus K get multiplied by A, then what happens? Then this also can be written as minus of K into A, or this also can be written as K into minus of A. These are the some properties of the scalar multiplication. I hope you got the terms. Now, today we have learned about the addition of matrices. We have discussed about the multiplication of matrices by a scalar, and now we will discuss the subtraction of matrices. These are the very simple topic. I know you understood all the terms. How we can do these. Subtraction of matrices. What is the condition for this? And condition remains the same as we have done for the addition. The order of the matrices remains the same. Here also the subtraction is possible only when if the two matrices A and B having the same order. Let us suppose that is A and B are two matrices of order. Order is m cross n. Both the matrices of the same order m cross n. Then their subtraction is denoted by, it is A minus B, or it can also be denoted by A plus minus of B. But you should note down the point. The order of both the matrices should be same. The example we can take A. Let us suppose A is any matrix. A is a matrix like 4, 5, 6, 3, 2, 9. This order is we know. This is 2 rows and 3 columns, 2 cross 3, and the other matrix B. Let us suppose 1, 2, 3, 3, 2, 1. This is order is again 2 cross 3. If we are going to find out A minus B, so we can also write this is A plus minus of B. So directly we can do, this is corresponding element can be subtracted from each other. Firstly we have to check the order is same or not. Yes, order is same. Now we can do the subtraction. This is 4 minus 1, 5 minus 2, 6 minus 3, 3 minus 3, 2 minus 2, and 9 minus of 1. The final result will be 3, 3, 3, 0, 0, 8. Hope you understood how the subtraction and the addition of the matrices is possible and how the scalar multiplication of the matrix we can do. So regarding this, I am going to upload one also PDF file, so you can do this and you can do some exercise for this.